Hi everyone, today we're talking about inverse functions and specifically on right triangles. So I kind of call this the basic inverse of functions because we're going to get into some bigger and better inverse functions here pretty soon once you understand the unit circle and angles that are greater than 90. So yesterday we were looking at right triangles and solving for missing side lengths. Well, that's all good and dandy, but what if you're missing an angle measure? What if you take a look at example 1 and you're like, well, I have two side lengths to my right triangle, but I don't know what theta is or angle B is. Today we're talking about how to find that angle measure. Hopefully you have a graphing calculator or a scientific will do just fine for today because we're going to need our inverse function button. So to start off, example 1, we're going to be solving the triangle. So I take a look and I put theta there because that's where I want us to start. Even though you could start at solving for angle A, take a look at angle theta. You want to be the angle, right? So put yourself at that theta. And I look at it as labeling my triangle. So I go, well, I know my hypotenuse. Okay, I know my opposite side, so I know actually my sine function. I know that sine of theta. Now theta is an angle measure, so you need to make sure that you always put a degree inside of the argument of sine, cosine, and tangent, and all the other trig functions as well. So sine of the angle measure of theta is equal to your opposite side divided by your hypotenuse of 17. And you're going to notice we're trying to solve for theta. We're trying to get to theta. So we actually have to undo the sine function. And how do you do that? Well, if you think back to all your inverse functions, like how do you undo a log? Well, you exponentiate it. How do you undo multiplication? You divide. Those are all inverse operations of each other. So the inverse operation of sine, which again we're going to talk about further later, is inverse sine. It has like a sign with a little -1 up in kind of like the exponent area. So you're going to inverse sine, and those will undo each other. But remember, whatever you do to one side of the equation, you have to do to the other side. So I'm going to squeak it in. We're going to go sine inverse of 15 divided by 17. So your theta will pop out. And remember, that's a degree. And that's equal to sine inverse of 15 divided by 17. Now you need to go to your graphing calculator or any scientific calculator with a sine button, and most likely what you're going to see is you're going to hit the second button, and then you're going to hit the sine button to get to the inverse sine button. And you need to make sure, most of you will probably have your graphing calculator set in radians. You need to switch 2 degrees. So I'm going to go capital degrees because we are working with a degree of the angle. Okay. So I get a angle measure of 61.93 degrees. And that is for your theta. So squeak that in, 61.93. Now to find angle A, what we can do is go angle A. We know that if C is 90, we know that B plus A would have to add up to be 90 for that whole entire triangle to add up, all the interior angles of that triangle to add up to be 180, right? So really your acute angles in that right triangle have to add up to be 90. So you can just go 90 minus 61.93 and you get yourself angle A, which is 28.07 degrees. All right, so that's angle A, we've got angle B, and what else are we missing? We're missing side BC. For me, I take a look and I see 17 on my hypotenuse and I see 15 as my opposite side. So I know my Pythagorean triple of 8, 15, and 17. And if 17 is on that hypotenuse, your missing side would have to be that 8. If you don't know your Pythagorean triples, I would suggest memorizing them. That would be in the last video. Or you can do Pythagorean theorem and solve for that 8. Our next example, we've got triangle ABC, and this time you're given the 2 legs of that right triangle. So we're going to solve that triangle, and I'm going to start out with finding angle C. Even though you could solve, any order you want, it doesn't matter. I'll just start with angle C. So I'm going to set up. Here's me. I'm going to label my triangle. I've got my opposite side. I've got my adjacent side. And frankly, I could solve for my hypotenuse right now, but I'm not going to need them for now. I'm going to set up tangent of C degrees is equal to your opposite side divided by your adjacent side. And we need to solve for C, and C is inside of the argument of the tangent function. So we're going to undo that tangent function by doing tangent inverse on both sides of your equation. So tangent inverse, you've got your 3/6. You could simplify that. I don't really care because I have a calculator. So C degrees is equal to tangent inverse of 3/6. So your C degrees I get as, and remember you're going to hit second tangent and you'll get that tangent inverse function, and then enter 3 divided by 6 and you get 26.57 degrees. We'll drop that in, 0.57 degrees. And to find angle A, similar to the last problem, we're going to take 90 and subtract your 26.57, and that gives you an angle A of 63.43 degrees. All right, and all that's left to find out of that triangle is your hypotenuse. So we'll use Pythagorean theorem for your AC. So I know AC squared is equal to 3 squared plus your 6 squared. So AC squared is equal to, that works out to be 45. Square root both sides. AC would be square root of 45. And I want you guys to really write in simplified radical form. In unit circle, we don't want to look at decimals, so make sure you're practicing right now your simplified radical form. You get 3 square root of 5. So 3 square root of 5 is your hypotenuse. All right. Example 3 doesn't really deal with inverse functions. I just feel like it's a nice time to talk about this problem. It could be like an extension of yesterday, and I think it'll help you for that supplemental worksheet also. So we've got a passenger in an airplane sees 2 towns directly to the left of his plane. So we've got, here is your airplane, okay, up in the sky, and you've got town and another town. Whoops. All right, so take a look at that. We've got an angle of depression from the airplane looking down to, let's call it, which one's my first town? What is the distance, Steve? Okay, so town 1 is called this one, and town 2 over here. So the angle of depression looking down at town 2 would be 15 degrees, and then the angle of depression looking down at town 1 would be 25 from the airplane. So part A, what is the distance D from the airplane to the first town? So we're actually solving for D. I take a look at, let me highlight the triangle. My pink triangle. I know that 25,000 feet is that perpendicular, and I'm trying to solve for D. So remember, your angle of depression is equal to your angle of elevation. So this 25 right here, I'm trying to highlight for you, 25 degrees is congruent to this 25 degrees of an angle of elevation from the ground looking up to the airplane. What we can do is solve for angle D using the side we know and taking the side we want, because we have an angle measure right now. So we have sine of, I guess I should highlight that, we've got B 25 degrees right here. Put yourself here. And so the 25,000 would be your opposite side, and D would be your hypotenuse. So that's why I chose sine. So sine of 25 degrees is equal to your opposite divided by your hypotenuse, which in this case is D. And then cross multiply and solve it. You get D is equal to 25,000 divided by sine of 25 degrees, and of course make sure you're in degrees, and you get 59155.04. So 59,155.04. All right, so that's the hypotenuse of that little right triangle there. And part B, what is the horizontal distance, x, from the airplane to the first town? So now in that same pink triangle, we're solving for x. And in this case, I don't really want to use the decimal that I just found in part A. I'm going to go back to that 25,000, so I'm a little bit more accurate. And x would be your adjacent side to that 25 degrees. So we'll set it up as tangent of 25 degrees is equal to your opposite, your 25,000, oh, that's changed, divided by your x value. Give it a little cross multiply and solve, so you get x is equal to 25,000 divided by tangent of 25 degrees, and that would be equal to 53,612.67. All right, so let's label a few things. We've got 53,612.67 there. Your hypotenuse, I can delete that. That would be 59,155.04. And our last question of today is, what is the distance y between the two towns? So y is actually right here. So y is the distance between the two towns, right? And explain the process you used to find the answer. So to me, I can't find a right triangle with just a side of y. So I'm going to look at the bigger picture. I'm going to erase my little pink triangle here so we don't get too confused here. I'm going to look at, maybe going white so you guys can see it. Hold on, let me erase a little bit more. So I'm going to look at maybe a white big triangle. and go, well, y is actually a piece out of that base of the big, let's go white triangle here. So if I can find the leg of that white triangle, I can just subtract out the x value that I already found, and then the leftover would be the y value. That's my plan, and that's my process that I'm going to use to find my answer. All right, so let me change colors back. We've got to find, I'm going to call that z, which is the whole white bottom piece of that triangle. So to find z, and then subtract x out of there. So I know I have a right triangle, and if I need an angle, so let's look back. Which angle, 15 or 25, would be congruent to this little guy right here? So which angle of depression would be congruent to the angle of elevation on my second tone? Well, take a look. I know I can't hear you. You should be yelling 15 degrees. Okay, so we're going to use our opposite side again and solve for our adjacent side. All right, so use tangent of 15 degrees is equal to 25,000 divided by our z value. Give it a little cross multiplying. So your z is equal to 25,000 divided by tangent of 15. And you get 93,301.27. But that is not what I was actually looking for. Remember to subtract out that x value. So subtract zoom in a little bit. Subtract x out. So 93301.27, and subtracting out your x value of 53,612 and 67. That will give you a y value of 39,688.6. Whoop, whoop. You did it. Okay, so that's your y value. So y is equal to 39,688.6. All right, everyone. Thank you very much for watching.